for the Algebra 1 assignment assigned March 30th, due April 5th. This is for problems 9 and 10. We're putting together learning targets 1 and 2. So we are graphing and identifying the key characteristics of the parabola that we graphed. So the first one we are graphing and identifying for y equals negative x plus 3 squared plus 4. So we're going to graph and then identify the key characteristics. So starting with the graph, we're going to identify the vertex first. That's how we go about graphing. So we say the vertex. We go the opposite of this number for the x. So it's negative 3. And then that number for our y. So here, if I put a negative 3 in for x, I get negative 3 plus 3 is 0. 0 squared is 0. Negative 0 is 0. And then plus 4. So that's our vertex, negative 3, 4. So that tells me on the graph, I want to start with negative on my x and positive on my y. And remember this right here, this is our a value, in this case of negative 1. It's just a negative, not a negative 2, not a negative 3, not a negative 1/2. It's just a negative, so it's like a negative 1. So that 149 for a regular x squared is now going to get multiplied by negative 1. So times negative 1, we get negative 1, negative 4, negative 9. So that's what we're going to do. From our vertex, we're going to go left to right 1, down 1, left to right 2, down 4, left to right 3, down 9. So here we go. So sketching out this graph. 1, 2, 3, 4. 1, 2, 3, 4. Negative 5. 1, 2, negative 3. Negative 6. 1 there. All right, so we can go like 5, 6, whatever. So let's go ahead and sketch this graph in. Negative 3, 4 is our vertex, so negative 3, 4. And we're going to label this because this one says, right, sketch the graph and label or identify the key components or key characteristics. So we're going to say vertex is here at negative 3, 4. And now I'm going to go left or right 1, and I'm going to go down 1. So left 1, down 1, right 1, down 1. And then I'm going to go left 2, down 4, right 2, down 4, and then left 3, down 9. So from 4 to negative 5 is going to be 9. Left 1, 2, 3, down 5. Or sorry, down 9, down 2, 5, right? Because that's down 9. 4 plus 5 is 9. So now we sketch in the curve. Hey, pretty nice. Okay, so we have graphed the parabola. Now we're going to go about identifying the rest of the key components here. So we have the vertex already, so that's what we start with. We can now identify the axis of symmetry. Axis of symmetry, which we can just say AOS for short. The axis of symmetry is at the x number of the vertex. It's that right in the middle there. So x equals negative 3 is the axis of symmetry. If I reflect this half of the graph over this axis of symmetry, it's going to line right up over there. Well, it's going to curve right up. So it's curved, not a line, but you get the idea. All right. So we got the axis of symmetry. Now we're going to talk about our x-intercepts. Our x-intercepts are right here where the graph crosses the x-axis. So we have an x-intercept of negative 5, 0. Whoop, almost made it 10. Negative 5, 0. And an x-intercept here at negative 1, 0. And we can find those just by counting. 1, 2, 3, 4, 5, negative 5, negative 1. The y-intercept is where this curve, where this parabola hits the y-axis. And that's right here. Y-intercept at 0 for the x, negative 5 for the y. Right, for our intercepts and for our vertex, we write it as a coordinate point, x number, comma, y number. All right, lastly, we're going to say where it's increasing and where it's decreasing. So we're going to say this function is increasing for all of the x's. Well, let's look, let's follow it as I go from left to right. the graph is going up, right? So all the way up until we hit the vertex there, and then it changes direction, right? Remember that vertex is where the direction changes, the highest point. So we're increasing, boop, top, and then it decreases. So for all the x's to the left of the axis of symmetry, in other words, all the x's that are less than -3, we are increasing. And then we are decreasing after the vertex. So all the x's that are bigger or greater than -3. So here we've got all of our information. Right, we've got the graph, we got the vertex, we got the axis of symmetry, we have the x-intercepts, we have the y-intercept, we have where it's increasing, where it's decreasing. And that's what's getting asked of you on problems 9 and 10. All right, and this, if we were doing comprehension checks, I would give you a problem like this for the comprehension check, because it's getting both learning targets. You're graphing and you're identifying all the points or the key characteristics. So let's do one more example, and then that'll be it, and you'll hopefully have taken all these notes, and hopefully those 10 problems, including these last 2, aren't too bad. All right, so problem 2, let's go with a different color here. So problem 2, we have, this is number 2, y equals 3 times x plus 2 squared plus 1. So in this case, we're gonna, all right, once again, find our x and y intercepts, we're going to find our vertex, axis symmetry, increasing, decreasing, all of that, but first we have to graph it. So to start the graph, we identify where is the vertex. I want you to stop and identify the vertex on your own. Go! Hit pause. Okay, hopefully you identified the vertex on your own, and you said, hey, it's the opposite of this, so it's -2, and it's that number for a y. So -2, 1. So the x is the opposite there, the y is that. So that's our vertex. And remember, whenever we've got this a value, that changes this 149. So right or left 1, right or left 2, right or left 3, instead of being 149 up, the 149 is now going to turn into, we're going to multiply it by 3, because that's our a value here. So it's a stretch by 3. So it's going to be 3, 12, 27. So with this, we're noticing like, hey, the vertex starts at -2, 1. And then I gotta, if I go over 3 left to right, I gotta get all the way up to 27. So when I sketch this graph, my y scale is going to be using some fairly large numbers. So what I'm going to do here, when I'm making my graph, is I'm going to make a big y. And I'm going to go by 5s. So I can get I don't want to write like 28 little dash marks. No thanks. I'm just going to go 5, 10, 15, 20, 25, 30. That'll be enough. And then what I'm going to do is I'm going to put each point, I'm going to label what the coordinates are on the graph when I actually graph it. And then here for my x-axis, I'm going to go by 1s. So 1, 2, -1, -2, -3, -4, -5. Sure. Now notice that scale on the x-axis and the scale on the y-axis are different, but each one is consistent with itself. The x's are all going by increments of 1. The y's are all going by increments of 5. What we don't want to see is I don't want you to go like 1, 2, 5, 7, 20. Right? If you're skipping numbers like that, that's where it gets all weird. So just make sure we have a consistent y scale and a consistent x scale. They can be different from each other, but they have to be consistent for each one. Okay, so starting with the vertex. Vertex is at -2, 1. That's where we start our graph. So that's just going to be right here. So I'm going to label it. Vertex is at -2, 1. And then I'm going to go to right or left 1. And I'm going to do this in blue. Right or left 1. And I'm going to go up 3. So I go over 1, I'm going to go up 3, and that's going to put me at 1 plus 3, because my y value on the vertex is 1. I'm going to go up 3, that's going to put me at 4 for my y number on both of these. So that point right there is 1, 4. that point right there is -3, 4. Now if I go 2 to the right or left, I'm going to go up 12. So my original y value of my vertex was 1. When I go 2 to the right, I'm going to add 12 to that 1. So it's going to put me at 13. So here, I get this point right there, which is, oh, sorry, this was a -1, 4. My bad, -1. So this is 0, 13, because 12 plus 1 is 13, and then -4 is going to be over here, -4, 13. Now, if I go 3 to the right or left from this -2 from the vertex, so 1, 2, 3 to the right, or 1, 2, 3 to the left, what's going to happen is I'm going to go up this 27. So I'm going to take this 1 from the vertex, I'm going to add 27 to it to get 28. So I go 1, 2, 3 to the right, and I go all the way up to 28 here. So I have 1, 28 right there. And then if I go 1, 2, 3 to the left, I go up to 28 on this because I'm adding 27 to that 1. So here I have -5, 27. So this is a little bit more complicated to graph because the numbers are so large, right? And we don't have grid paper, so we just gotta like add it instead of count them up. But you can see we still have that same general shape. Make sure you're putting arrows on the end to symbolize that, hey, it's going to continue in that pattern. So there we go. We have graphed it. Now we're going to go about labeling or identifying all the key characteristics. So axis of symmetry. We've got our vertex. Axis of symmetry is going to be, let's go yellow. Yellow right here. This is what we would fold that parabola over. So it's like that, right in the middle. It's always, so axis of symmetry is x equals -2. It's always x equals the x number of the vertex. So we got the axis of symmetry. Now we need our x-intercepts. If I go along this parabola, what's going to happen is I've got positive numbers, positive numbers for my y's, positives. The x-intercepts is where it crosses the x-axis, or when y equals 0. Here, my y values are all going to be positive, and this graph is never going to cross the x-axis. So here, there are no x-intercepts. That can happen. We have a graph that's above the x-axis, right? The vertex is at -2, 1, y value of 1, and it's going up. So it never hits or crosses the x-axis. So there are no x-intercepts. And that's what we write when it says, what are the x-intercepts? There are none. Okay, so now the y-intercept, hey, every parabola is going to have a y-intercept, as long as it's not a contextual problem with some weird domain. So here, if I follow this graph, that's my y-intercept. So the y-intercept, sept with a C, is 0, 13. All right, so we've got our vertex, axis of symmetry, no x-intercepts, because it doesn't have any. What the y-intercept is, now we got to go increasing and decreasing. So the graph is, let's stay with pink. Pink shows up pretty well. So it's increasing. Well, here as I go from left to right, we go down, 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 and then hit the vertex, and we go up, 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 up. We're increasing to the right of the vertex on this one because it is opening up. So it's increasing for the x's that are greater than -2, that are bigger than that x value of the vertex. It is decreasing over here. So it's decreasing for the x's that are less than -2. Everything on this side, the graph is going down from left to right. Everything to the right, the graph is going up from left to right. So those are two examples, very, very similar to what you're going to see on problems 9 and 10 for the assignment. Hopefully you can do it just from these videos. So let me know if you have questions by emailing me, sending me a message on Remind, commenting on this YouTube video, or virtually showing up to my office hours. So good luck on the assignment.